Hey guys, we are going to go ahead and move on to 2.3. And 2.3 is called Other Set Operations. And the notes for it are actually the same notes as those 2.2. So the last problem when we did about 2.2 about well-defined, we're in that same packet. Okay, and I omitted a bunch of problems, 2, 5, 6, 19, because they were just too much. I think everything else you can handle. But let's see. Okay, so first off in 2.3, we learned two symbols. Union looks like a U, and it means every element from both sets. So first, let's look over here at A. It says S union V. So that means both, as in everything from S and everything from V. So let's see. First, we kind of have to figure out what the heck S and V are, because it looks like N is easy. It's 1, 2, 3, 4. S is not quite so easy. It says S is equal to some kind of equation with 2n minus 1? What? What is 2n minus 1? It's some kind of special number. It always produces some kind of special number. Let's plug in 0 and see what happens. Then plug in 1. Then plug in 2. Then plug in 3. When I do this, we'll see that every number that pops out has something special about it. Like for instance, I get -1, then 1, then 3, then 5. What are all these numbers called? 1, 3, 5. They're called odd numbers. So 2n minus 1 is the odds. So that was that S. So I'm just going to go down here and I'm going to say S is the list of all odd numbers. Let's see what T is. T says just 2n. Okay, well, let's plug in some numbers. If I plug in a 0, 2 times 0, and a 1, and a 2, and a 3, what kind of numbers pop out? I get 0, 2, 4, 6. What's a special name for that? That's called evens. Okay, let's see what this Hui says about x equals 2n plus 1 for the letter V. Oh gosh, so that's another one. So V is 2n plus 1. And it says we can plug in n equals 0 or anything else in capital N. Remember, capital N are the numbers we count with on our fingers. Like 1, 2, 3, 4, 5. And it says we can use 0. So let's see here. 2 times 0 plus 1. 2 times 1 plus 1. 2 times 2 plus 1. And I get 1, 3, 5. Oh, okay. Those are the odds again. Okay, so let's see here. Now that we figured out some words to describe these sets, let's go back up to part A. Part A says, what is S union V, as in include everything from S and V? Well, from S, we have all the odds. From the V, we have, again, all the odds. So the union is all the odds we got from the S and all the odd answers we got from the V. So the odds, remember, were 1, 3, 5, 7, 9, da, 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 da. Oop, and let's put some squiggles. So the simplest possible expression for this 1, 3, 5, 7, 9, 11, blah, 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 is you can just say S or V, because you have to include everything from the S and everything from the V. So anytime you have a U, it means or. So for part B, I see another or. So it's going to be S or T. And let's remember, S's are the odds, T's are the evens. So S or T would mean both, as in the odds, one, and the evens, all the way to the end. Okay, part C is a little different. Part C has that weird mountain looking thing. Let's see what that says. Intersection means that's what's in common between both sets. So for part C is what's in common between S and T. Well, let's see. S is odds, remember? Okay. T is evens, remember? What's in common between odd numbers and even numbers? And the answer is nothing's in common between odd numbers and even numbers. So the answer is 0 with a slash through it. Okay, now we're going to do some Venn diagrams. Okay, the next little notation that I need to show you is this A with a line over it. That means everything that's not in A. So if here's my Venn diagram and here's my A, yeah, everything not in A would be out here. So A would be inside, and not A would be everything outside. So anytime it has this little bar on top, it means everything but that. So if it asked me for a Venn diagram of A with a bar on top, it means everything that's not in that A. So everything out here would be shaded. Okay, let's look at this sucker to the right. It says, shade the portion of the diagram that illustrates the set. Okay, well, first, let's remember what these weird little symbols mean. The one that looks like a mountain means it's what's in common. The one with the U means you shade everything. So let me write that down maybe. The mountain thing is what's in common. And the U looking thing is where you shade all or both. So let's see here. Let's look at our example. First, we're going to do the parentheses. So in this first parentheses, it says A and B, as in what's in common. So let's look for what's in common between A and B. So here's my A circle. Here's my B circle. And where do they overlap? Right here. So that's what we got from our first set of parentheses. Now let's look at our second set of parentheses. It says A and C. And again, that upside down mountain means what's in common. So let's see here. My A circle is this one. My C circle is this one. And I want to outline what's in common between these two circles when they overlap. So it's this guy. Okay. Now it says, so we have the pink from the left parentheses, the green from the right parentheses. Now it has this weird U in between that means shade all or both. So that means my final answer is going to have the pink part and the green part, because we have to shade both. What? So the pink is the overlap from the first set of parentheses. The green is the overlap from the second parentheses. The blue is where we include everything from both. Okay, let's look at this sucker. It says J, and so that means in common. C with the bar on it. That means everything but C. Well, let's find this. Okay, J is this circle. Woohoo! Now, where is everything but C? Well, everything but C is everything out here, everything out here, everything out here, everything out here, and everything in here, everything in here. Okay, so the blue represents the part that's not C. This pink represents the part that's J. So J is this pink circle. Everything but C is the blue. And then this and means what's in common. So it's saying what's in common between my blue and my pink that I shaded. And it's this janky area in here. Yeah. Okay, let's go to another one. Again, we're going to start with the parentheses. Okay, so this first parentheses has the in common, the intersection, and. So let's find what's in common between A and B. So here's my A circle. Here's my B circle. In common is this overlap. Okay, now let's find the other piece of parentheses. This B intersection C, or B and C, as in what's in common. So what's in common between the B circle and the C circle? Well, the answer is nothing. Nothing's in common. Okay. The very last thing is to worry about this symbol in between the parentheses. It says U, as in shade all. Okay, so I'm going to shade everything I got from this first parentheses, which was this overlap, and everything I got from the second parentheses, which was nothing, and that's my final answer. So I shade the stuff from the first parentheses, then from the second parentheses we had nothing, so I don't have to shade anything for that. So my answer is just this little smidge right in the inside. Okay, let's go another one. Okay, this time we're going to give you numbers, and we have to figure out where the numbers go. So it says, in a fraternity with 41 members, 18 take math, 5 take both math and physics, and 8 take neither math nor physics. How many take physics but not math? Okay. So this whole rectangle represents the fraternity of 41 people. It says 8 people take neither math nor physics. That means that there's 8 people outside these two circles. So 8 represents the outside of these two circles. Okay, let's see what other numbers they gave us. They said 5 take both math and physics. So both math and physics is this inside. Okay, let's keep going. It says 18 take math. Well, that means this whole circle is 18. The whole circle is 18. So how can we figure out just this crescent moon right here? Well, if the whole circle is 18, and this little smidge overlap in here is 5, we can subtract those. And so the math, just math people, should be 13. Okay, now let's talk about these physics people. I think I've dealt with all my numbers except for that number 41. So let's think about this. All these people represent 41. So if I'm trying to find this leftover, I can just take all these people and subtract them from 41. So 41 minus the 13 from just the math, minus the 5 from the overlap, minus the 8 from the outside, gives me 15. So that means everything that's left over in this one circle is 15. Not the whole physics circle, just that part that was left empty is 15. So the question is, how many take physics but not math? Well, it's these people, 15. Ooh. Okay. Again, this one's the same-ish, but they just give you the information real wonky. It says, fill in the Venn diagram with the appropriate numbers based on the following information. Okay, so it says N of A is 34, but that means the whole A is 34, the whole thing. Then for B, the whole thing is 37. For C, the whole thing of his is 24. And then it says a bunch of other stuff. Okay, the one we're gonna look for first is the one that says the most symbols. And let's remember what these symbols mean. This and means what's in common. So this is saying there are 2 people in common between A, B, and C. Well, look at our circles. Where's the in common between A, B, and C? It should be right here. That's in common because it's in the A circle, it's in the B circle, and it's in the C circle. So that's 2. Yay. Okay, now let's keep going. Now we can only do, let's look for whatever has one less symbol. So we just looked for the longest one. Now let's look for the next to shortest one. Looks like this sucker. It says A and C is 8. So that means the overlap from A and C is 8. So the overlap is this whole thing. But if I want to know just this VII, I'm going to take 8, because the whole thing is 8, and I'm going to subtract 2. So this right there, I'm going to say 8 minus 2, and that gives me 6. So we have 2 in the very middle. We have 6 right there. Let's see what else we got. We got B and C is 18. Again, that's what's in common. So let's look between B and C. Here's my B circle. Here's my C circle. In between B and C, as in this whole overlap, is 13. This whole blue overlap, all of it is 13. But if I want to find the piece without this 2, I'm going to take 13 and minus 2, and that gives me 11. So I know there's an 11 right here, a 6 here, and a 2 here. Okay, let's keep going. It says A and B is 14. So that means the overlap of the A circle and the overlap of the B circle is this middle part with the 2 and the VI. And to figure out that VI, we're going to say 14 minus that overlap of 2 is 12. Okay, now we just have to figure out the remaining sections. Well, we know A is 34. So to figure out what this remaining piece of A is, we're going to take 34 And we're going to subtract off what this VI is, and that's 12. Then we're going to subtract off this green overlap of a 2. Then we're going to subtract off this bottom left piece of 6. And that should give me this piece of the A that is not overlapping with anything. So let's see, 34 minus 12 minus 2 minus 6, 14. And then we're going to do the same thing on the right and the bottom. So B is, all of B is 37, but we're going to subtract off any number that is in the B circle. So 12, 2, and now this time 11. I got 12. So up in this little area of IV, we just have a 12. The only thing left we haven't found is this C. All of C is 24, so we're going to say 24 minus any numbers that were from the C circles. So this 6, this 2, and this 11. Hey, and we get 5. So on this homework problem, it'll probably say something like Roman numeral 2 equals, and you'll put 14 because that's what this circle is. Or it'll say Roman numeral IV, and you'll say that it's equal to 12. Okay, let's keep going. The next ones are actually, you kind of already know how to do it. So it's kind of a refresher. This part A says write 14 through 19 using set builder notation. Okay, set builder notation looks like this part B, where there's squiggles, we have an X and an up and down line, and then we say that all the numbers from this 14 through 19 are natural numbers or whole numbers because they're numbers that you can count on with your fingers and toes. So to say that they're natural, we're going to say X is an element of capital N. And then we need some sort of alligators to describe 14 through 19. So let's see, since it's a list of numbers, I'm going to say all the X's are in between 14 through 19, as in they're either bigger than 14 or less than 19. And I'm going to put the equals because that means we include 14 and 19. So our set builder is squiggles, X, up and down, bar, X is an element of the natural numbers, and 14 less than equal to X less than or equal to 19. Okay, for part B, it says write it using the listing method. Well, that's just backwards of part A. As in, part A wants us to write it in part B form, and part B wants us to write it in part A form. So they want us to take away this X and this up and down bar, and instead they just want us to list the numbers. It says X is equal to 4N when N is 3, 6, or 9. Well, we need to plug in 3, 6, and 9 into this 4N. So 4 times 3, 4 times 6, 4 times 9, and whatever we get for this, that goes in our list of commas. So I got 12, 24, 36. So again, you're not typing in the 369. You have to plug that into that little bitty baby formula right there. Okay, the next one says, find the number of elements in the following sets. Well, we did that way back in the day. It's the cardinal number, And we do not repeat. So it says, find the number of elements in the following set. Well, if it's a letter from the word nationalization, that means I could have an A in there, or an N, or a T, or an I, or an O. But then the next N repeats. So I'm not going to include that because I already wrote it. Then another A, I'm not going to include that. An L, an I, I'm not going to include that. Z, A, not going to include that. T, not going to include that. I, O, everything else is repeated. So I just wrote out all the different letters and I did not repeat. And now let's count. 1, 2, 3, 4, 5, 6, 7. There's 7 elements because you don't include the repeats. Okay, last one. This is kind of lame and we kind of already know how to do this. It says, Jose has 4 pairs of slacks, 2 shirts, and 4 sweaters. How many combinations can he choose if he chooses a pair of slacks, a shirt, and a sweater for each day? So he has to pick a pair of pants, a shirt, and a sweater. And we're going to multiply all those. Well, let's think about this. How many different pairs of slacks does he have? 4. How many different shirts does he have? 2. And how many sweaters does he have? 4 again. So to find the total amount of possibilities, we're just going to multiply this up. 4 times 2 times 4 is, was that 32? Bam, done with that problem. That one was kind of strange. It seemed like it did not fit.